So we're still being asked to find the sum of a geometric series, except now what's missing is we don't know how many terms are actually in the series. That's why we have the hint that we'll need to use two formulas. The first thing we need to do is to find n. So we need to actually go back to the geometric sequence formula. Looking at this, we have T1 is 1/27th, which we'll have better luck dealing with that as a decimal, 0.037 repeating. Tn, the last term, that's 729. N's obviously what we're trying to figure out. And finding R is actually less obvious in this situation than in others. We don't really know what we need to multiply by going from 1/27th to 1/9 to 1/3 and so on. So to calculate R, we need to do that off to the side. To find R in any situation, we take the second term and divide it by the first term. So we take 1/9, or 0.1 repeating, divide that by the first term, 0.037 repeating, and again, since these are decimals, it's important to actually put in more than just 1 or 2 decimal places. We do that and we get that R is 3. We can go to the sequence formula. And fill in what we know. Good first step here would be to divide by 0.037 repeating. And at this point we come up to a type of equation that we've never actually seen before. We've never had to deal with a variable in the exponent. So the way we need to deal with this is we know that 19,683 is going to have to equal 3 to the power of something. So at this point, it's not a bad idea to go to the calculator and start guessing. Type in 3 to the power of 5. 243. Not big enough. 3 to the power of 6. 729. Still not big enough. Keep guessing, keep going at it. Eventually what you'll find is that 19,683 is 3 to the power of 9. Now that we know this, we can actually cancel off the 3's and deal with the exponents individually. So we know that 9 is n minus 1. Move the 1 over, and we get that n is 10. Now that we have what n is, we can go back to the geometric series formula, and we can figure out the sum. So now the sum is what we don't know. T1 hasn't changed. Neither has R. And n we just found is 10. Using the formula and filling in, do 3 to the power of 10, 59,049, do 3 minus 1, it's 2, do 59,049 minus 1, that's 59,048. Go and type this into the calculator, and what we find when we do that is we're going to get a decimal answer, which makes sense because we had fractions that we were adding. Customary is to take this to 2 decimal places, so that would give us 1093.48.